Hello, welcome to the course Electronic System Design. Last two lectures we saw the basic steps what we follow to create the schematic in KiCad and the PCB in KiCad. So, first we design the schematic, we import the symbols whatever the component we need. We import the symbol, connect them together to make a complete circuit, and then we import that as a PCB in PCB editor and we arrange them as per our desired location, and then we route the ret nest. So, ret nest says that this is the connection need to be made, and that we connect using multiple layers, for example, front copper or back copper or some intermediate layer using vias. So, that we saw, but we still need to discuss one very important concept, how to create the custom symbols and custom layout of your particular device. So, though KiCad has very good library support, it has so many components available in its library, the footprint and the symbol. However, many a time when you start designing a circuit, you figure out that you need a particular type of operational amplifier or particular type of NAND gate with so and so specification, and then when you start designing that schematic, you will realize that this particular component is not available, though there are so many op amps available in KiCad library, but that particular op amp which you need for your schematic, it is not available either as a symbol or as a PCB layout. So, in that case we need to custom design your schematic symbol and custom design your PCB layout for that particular component. So, for example, you are using hundreds of components in your PCB, one particular component is not available in KiCad library. So, today we are going to discuss, if this is the case, if one component or two components are missing in the library, how do you custom design those symbols and PCB footprint, and you can use it in your normal schematics where you are using other hundreds of or 50s of other components. So, we will see today the custom design of symbol and footprint. So, let us go to the software. So, custom symbols and footprints. So, in this case, last lecture we discussed a simple circuit where we are using a battery which is feeding a LED through a resistor. So, that was a very small schematic, and now we want to use a custom component which is a switch here. So, in the last lecture the battery was driving this LED continuously. We want to put a switch in between so that we can turn it on and off as per our desire. So, we want to develop a switch symbol and associated footprint which we will use then in the earlier schematic and PCB, and then we will see how it is done. So, the last circuit would be improved by adding a switch to turn on the LED. To do this, we need to have a symbol, and next thing we need the associated footprint. So in this case, we are going to add a simple SPST switch, or a single pole single throw we call it. So we will design a SPST switch. SPST switch is single pole single throw. It means we have this kind of switch. When we will make the connection, so only one connection will be made, which is, let's say, from this point A to point B. When we will move this switch in a single movement, one connection will be made from A to B. In the other movement, when we will move this switch upward, there will be one disconnection from A to B. That's why it's called single pole single throw. If we have, let's say, single pole dual throw, or we call SPDT, so this switch is SPST. For example, if we want to have SPDT switch, in that case we have two connections. This is A, this is B and C. In this case, we will have this kind of arrangement. When we will make a move or at this switch, one connection will be terminated from A to B and the other will be made from A to C. So in the one movement, two connections will be affected, B will be disconnected and C will be connected. So we call it SPDT switch. These are very frequently used terms for the switch in the schematic. So this is SPST switch, this is SPDT switch. So we are going to design a simple SPST switch which we will use in the schematic. To do this, first we need to know that the libraries in the KiCad, there are so many libraries available. So one library we can dedicate for the custom switches, we can dedicate another library to the operational amplifiers or some other custom semiconductor devices. So all these libraries, they are included using a library table in the software. So we have something called library and library tables. So library is nothing but the collection of all the symbols or footprint. Whatever components you want to have, they are all arranged in a particular library. So library can be a switch library. We have so many switches which we can develop for our custom design and put it in a particular library called switch. So there are so many libraries for different type of switches. Library table is nothing but it contains the name of the library and the associated path where this library is kept in the software. So for example, we have 10 libraries: op amp, combinational circuits, sequential circuits, and so on. So this library table will have entries only where op-amp will be written and the associated path of the library will be written. So that is called a library table. So symbols and footprints are organized into libraries. So any particular library can either hold symbols or footprint. So a single library cannot hold both of the components. It cannot hold symbols as well as library. For symbols will be separate library and the footprint will be a separate library. So KiCad keep track of the user's symbol library and footprint in the symbol library table. So KiCad keep tracks of symbol and footprints libraries in symbol library table and footprint library table. So these you can access to access the symbol library table. You can go to Tools Preferences and then Manage Symbol Libraries. And to access the footprint library table, you can go to Preferences and Manage Footprint Libraries. So this is how you can access these various libraries which you are going to build up for your schematic over the time. So next let's see how do we create new library, new project in the library and create new symbol. So creating new global or project libraries. So when you are creating libraries, you can create two types of library. One is the global library, in which you will develop a part, a schematic or a symbol that will be available across all of your projects, which is called the global library, and all the components you develop in this library, you can use it in any of the schematic or any of the project you have in the same software. You can freely use it. However, sometime you want to use a project library only, where you need a schematic or a particular symbol or footprint only for that project. So in that case, you can develop a project library, and that components in the project library will be accessible only for that particular project. It will not be available to all other projects in your library. So in that way, you can partition, or you can have limited access to other projects, and you can develop a project library only for that particular project. To do that, you can click on the file and go to new library and select project. So this will create a project library. File and go to new library and select project. So you can choose, while creating this, you can choose project as well as global, both are fine. So when you do that, then you have to put a name for your library. Choose a name for the new library. So this is how you can create project or global library. Once you create it, after that we need to create a new symbol into this. So creating a new symbol. To create this new symbol, you need to go to File and go to New Symbol. So once you click on this new symbol, this kind of dialog box will open. So this is the dialog box for new symbol creation, and many things are self-explanatory. For example, you need to put a symbol name, what you want to call it. So here we are developing, let's say, this part which we just purchased from the market. and the symbol and footprint is not available in the KiCad. So we give it the symbol name, which is this M2011S3A1W0C03. So this is the symbol name which you enter in the symbol name field. Then default reference designator. So this you would like to change it to SW with, so all these software generally has some reference designator. For example, if we want to develop a symbol or footprint for resistance, so the reference designator is R, which is universally acceptable in all the software. Whenever we have a resistance value need to define, we generally start that with a capital letter R. The capacitance is again a standard reference designator is there, which is C. All the components which are in capacitance, which are specified by capacitance, that generally start with C. So here for the switch we would like to have it like SW in the reference designator. You can write that as the reference designator here in this new symbol dialog box. All other fields can remain just like default whatever is given. So you can keep it same and you then click on the OK button. It will create a new symbol in your symbol dialog box. So once you click on OK, then this will lead to your symbol pins assignment and pin declaration. So in this window, you need to specify the pin properties. So here we want to define now what are the number of pins we are going to use for this particular component, which is a switch. So in this dialog box, we want to give each pin a particular name. For example, we are developing SPST switch here. So SPST switch is something like this. And we want to, let's say, give it a name, terminal A here and terminal B here. So this is the name of that particular pin. So we are designing a pin here. So we are creating this first pin, which is pin name A. Pin number, any number you want to give. So let's say for example we are giving here 2 and 3. So this is pin number 2 and electrical type is passive and Y position you can keep it by default. Later on we will be changing it by moving it in the schematic. So this is how we feed all these values and keep all the things default. You can however change it. It's not going to impact your electrical performance by changing these text. This is just for the visual representation. So start designing the symbol by adding a pin. So for this we need to click the add a pin button. We set the properties as follows. We put the pin name as A. You can name it to anything, whatever is meaningful. We put pin number to 2. You can put again any number. It should not be repetitive. We need to have distinct pin numbers for all the pins whatever we are going to create, and rest of the things you can keep as it is and then click OK. Once you click it, this will be created here in your symbol editor. This is your symbol editor window where this pin will be visible like this. However, when we created this symbol, this circle was on the left side. We need to put it on the right side, just like here with A, this circle. So we will select it and then press R to rotate it. We do it 2 times. So this pin will be rotated, and this circle in one pressing of R, 90-degree rotation will be there. So once it will be 90-degree rotated, and in the next if you press R, then it will be coming to the right side. So you rotate the symbol so that it matches what we want to make. So we rotate clockwise. To make it something like this. Then again we need to create the second pin using the same button, and we write the pin name as B and the number is 3. Rotation we need not to rotate, we need the circle this side only. Then this extra line we need to add just for our representation that this is a switch. If we leave it just by these 2 lines, it's not going to impact any electrical property of the symbol what we are designing, but for a representation point of view, by looking at this symbol we need to understand that this is a switch. So for switch, a universal symbol is this line which you can toggle if you apply the input. So this switch you can close or you can make it open. So this line, extra line, you can put by graphical features. There are many graphical features available on the right side of this screen. To do that, you can select, for example, this line and draw this line from this point to this point. Wherever you will click from here to here, this line will be visible. Similarly, you have so many shapes you can add. For example, if you want to add a box also across this, you can click on this box and put something like this. This is also possible. This is just for our representation that there is a box, inside that there is a switch which we can turn it on and off. This has nothing to do with the electrical performance of what we are going to design. So once this symbol is prepared, now we go to the symbol properties. So this you can open by File and then Symbol Properties. You go to File and go to Symbol Properties. Here this dialog box will open, which is saying the library symbol properties, and here you can specify many things. For example, the reference is SW, which is a switch, and the keyword is SPST switch toggle. For example, this is the keyword we want to give it to this component, because later on, after few days or few months, when you will search in your library that I want to use the switch, so you may not find it by this exact name, you may not even remember this exact name. You want to find that time a suitable switch for your schematic. So you will, when you will search the word switch, this keyword will be handy. If that search is matching this keyword, this component will show up in your search. So symbol name can be a manufacturer given, or when you purchase the component that comes with its symbol name. So that can be that complicated alphanumeric number. But in keywords you can specify your keywords, you can write any number of keywords here, so that when you come back later on to the software and search for the switch, this particular switch will show up in your search result. If it is suitable, you can choose this switch for your next design. So you use keywords to make it easier to find the symbol by searching. So you write the keyword here. We can see some more fields which we are not using currently. One is this footprint field, where you can specify the path of that particular footprint. So this option we will be choosing later on when we will develop the footprint. That time we need to associate that footprint to this path. The next is this data sheet. This is also very important field. When you are buying your component from the market, which is already not there in KiCad, so that time we can have this name, this symbol of component what we purchased. We can search on internet the associated data sheet, what are the electrical specifications of this particular component, and we can add the path of that data sheet at this point. So later on when we will search this switch, this data sheet will also be available to us. So that time it will help us that electrically whether this component is suitable for our design or not. So, it is always advisable to have a associated data sheet specified here in this field. So, once you fill all these values, you click on OK and the new symbol will be created in your symbol editor. So, once the symbol is created, you can still use it in the schematic, but you cannot generate a PCB using it because there is no associated footprint. So, next step after creating symbol is to create a new footprint. So, to do this, we need to open the footprint editor and create a new project specific footprint library. So, this you can do by going to file and new library. So, you go to file and click on new library. It will ask you whether it should be global or it's a project library. So, once you click on new library, you need to choose project and global, and you need to specify your name, what you want to give to this footprint library. The new footprint library will be added to project library table. So, this is the KiCad software window where we click on the footprint editor. This is your footprint editor. You click on this and will generate the footprint editor window. So, this is your footprint editor window. When you open this footprint editor window and you are creating a new library, so that library is added into your project file. So, for example, we have given a name getting_started. So, this particular field will be added to your project file in this software window. Now, we go to project this footprint editor window and need to create a new footprint for our SPST switch which we just developed the symbol. So, we go to the new footprint by going to file and new footprint. So we go to File and New Footprint. Now we give it any desired name which is meaningful. So for example, here we are specifying the footprint name, which is switch toggle SPST something, and then the part name. At the same time, we need to specify the footprint type. So there are two types of footprints which are widely used. One is the through hole and the second is SMD. Through hole is where we have the extended pins which go through the PCB. For this we need to make it hole in the PCB. Both the pins will go across the PCB and on the other side we solder the component. That is called the through hole. SMD is we do not make the hole in the PCB. On the PCB top layer itself, we create landing patterns using some pads, some metals, and we place the component on top of it and we heat it, the whole assembly, and the connection will be made because the solder will melt and make the electrical connection. So that is SMD type. So we can choose any one of this footprint type, SMD or through hole. So for this particular component we are selecting the through hole. You can choose any one of it. For this example we are taking the through hole. Next we create the pad for the footprint. So pad is the pattern where the component pin will be landing. So this is like a circular type of ring and in between we see this space. This is the hole where the PCB will be drilled a hole of particular thickness. So our pin will go into this hole and soldered on the other side of PCB. This ring is made up of a material which is solder, we call it, that is used to create electrical connection to the component. So to create this footprint pad, we go to, on the right side we have a option add pad. So this is the option where we need to click and use the add a pad tool. Once you click it, then you place the pad and then double click on the pad to edit its properties. and change the pad number to 2. So here we need to note that this number is what we have already defined in the schematic. So if the symbol has 5 pads, for example, the footprint will also have 5 pads only, and the numbering of those pads are linked to the numbering we defined in the symbol itself. So in the symbol, if we remember, we made this symbol like this. This was A and B. Here this was 2 and 3. This was the number. So here we need to keep the pad number exactly same, which is 2 and 3. So this pad which we are developing here, this is the pad which is linked to this pin A of the symbol. So this number we need to keep exactly same. Once we make this pad, then we can go back again, add a pin and create the second pin there and give it the pad number 2. So here the pad type we have already defined, which is through hole. This is pad number 2. The position we will make it change by moving it in the schematic itself. Here one more thing we need to note down is the hole shape and diameter. So hole shape for the schematic is this window where we are going to make the hole and the pin of component need to go there. So that we need to check carefully what is the thickness of the pins of the extension wire we have in the components, the diameter of that, and our hole diameter should be exactly same or little bigger than that wire, so that it can go comfortably into the hole. So this hole shape and diameter we need to carefully check with our purchased component. So once we make these two pads, we can go to footprint graphics. So for footprint graphics, we have so many options. For example, we have the FFab, the fabrication layer. The F silk screen. This is the front silk screen layer. We have courtyard. This is the front courtyard. So all those layers we are putting across this symbol. So these are the pads we have created, and this is the layer. For example, this is courtyard layer. It means no any other component. For example, we have some transistor here, some capacitor here. So no component should go closer than this boundary. So and this boundary is reserved only for the switch. Any component should not be placed which is overlapping this boundary. So this is something called courtyard. So we can define many layers across this schematic now, whatever is required, and then the final scheme, the PCB or the footprint should look something like this. So once we make this footprint, now we need to attach this footprint to our symbol which we have already made. So we are attaching here the footprint to symbol. To do this, we again go back to our library and we open the library symbol properties which we just saw in 4-5 slides back, and in the footprint field we now need to define the path of that footprint. So go to symbol editor and open switch symbol. Edit properties. Click in footprint field. Which is this field. If you click on it, then browse to the project footprint library. There is a small option on the right. If you click on it, this will open the browser dialog box. You can browse to the footprint library. And select the switch footprint. So now our symbol is attached to footprint, and now we can use it to make any PCB. So we go back to our earlier design where we used this switch. So earlier we have already created this circuit in which we have this battery which is feeding this LED through this limiting resistor. Now we are inserting a switch which we have developed here in this schematic. So this is using custom symbol into schematic. So we open the schematic. Add new symbol. After adding this, we need to make the connections. For example, this pin 2 is connected to the battery terminal and this pin 3 is connected to the resistance. So we make the electrical connections. Once we are done, the most important part here is to run the electrical rule check or ERC. So for every change we need to run again the ERC to make sure that we are not making any error in the electrical connections. Once this is passed, we go to the option update the PCB from schematic. So we switch to layout. So for this we have command tools and then update PCB from schematic. So once we click on it, the earlier PCB what we designed in the last lecture, in that PCB this extra footprint will be visible, which is our developed new switch. This has footprint something like this. Now these all the red nets are already made connection by electrical layers. These extra red nets will be visible here. So what we need to do, we need to remove these already existing connections and we need to route these extra two red nest using the metallic layer, front copper or back copper. So we delete earlier connections. And then route the new traces. Once we route the new traces, this footprint will be connected to the circuit, and again we need to run DRC, the design rule check, if to make sure we are not violating any design rule. So once it passes, then we get our complete PCB with custom symbol. So this is our PCB using custom symbol. So this is the complete flow of how do we develop a custom symbol and footprint in the KiCad. This is very often used because there is a possibility that we want a particular component which is already not available in KiCad. So it should not stop us from using that component because electrically that is what most suitable for my design. So in that case I design a custom symbol and custom footprint as per the data sheet of that particular component, and this is how we can use this custom design in our already existing PCB to create a complete system. So this is all for today. Thank you.